Hey, sixth period geometry students, I just wanted to help finish up your notes here. And I just want you to understand you guys did all the work beforehand building this, but we need to remember what we did. So looking back here, remember we took the two squares that were similar. We found their similarity ratio and the ratio of the perimeters. So remember, you use SR for similarity ratio, and then I'm going to use ratio of perimeter is going to be RP. And we found that they are equal because they have linear measurements. And when you're similar, the linear measurements all have the same similar ratio or scale factor. And then we talked about the relationship for area, and we were right here at the bottom of 5. And I want to show you really cool how close the relationship and similarity ratio works. So I'm going to change ink color here on my pen. And I'm going to let you notice something. The ratio of area is really your similarity ratio squared. For instance, look at 1/2. That's your similarity ratio. Square it, which means you square the top, you square the bottom, and you get 1/4. That is your ratio of area. Notice all you have to do is square your similarity ratio. So let's plug in what we know. So for proportional perimeters and areas theorem, what do we have? If two figures are similar and have the similarity ratio of, and we're going to just use a generic ratio of A to B, then the ratio of their perimeters is A to B, and the ratio of their areas is A squared to B squared. So the cool thing is now we can set up ratios and proportions to set up new problems that we can actually solve for perimeter and area as well. So let's do some of these problems together. And just remember, similarity ratio, I'm going to use with this as SR to represent similarity ratio. Ratio of perimeters, RP, and ratio of areas, I'm going to use as RA. Just keep it pretty simple. Now, for the following, it says, for the pair of similar figures, find the ratio of perimeters and the ratio of the areas. Now, remember, I gave you the fact these two triangles are similar. Now, that means I should be able to find a similarity ratio between the two if I have a pair of corresponding sides. And if you notice, here's my pair of corresponding sides. So how about if we go from smaller to bigger in this case? So my similarity ratio of corresponding side to the other corresponding side, remember they're opposite the angles, they're the same size, is 3 to 5. But using the theorem up above, what do we know? If we know the similarity ratio, we know the similarity ratio and the ratio of perimeters are equal, right? Then we can sit there and say we automatically know the ratio of perimeter. The ratio of perimeter is just going to be 3 to 5. Now, how do I solve for the ratio of areas? Well, what does the theorem say? Oh, there's a typo there. It says that you take your similarity ratio and you square it. So ratio of area, I just got to square my similarity ratio. So I square the 3 and I square the 5 and I get 9 is to 25. So that's your ratio of your areas. Now, how can we use that to solve for the other ratios? Well, this is really cool. So make sure you have your notes out while you're doing your homework. The following, it says, find the similarity ratio and the ratio of perimeters of each pair of similar figures, okay? So now they said we have two regular hexagons, and so we're looking for the similarity, because remember they already told us they're similar. But they gave you one of the three. They either give you similarity ratio, ratio of perimeter, or they give you the ratio of areas. Notice they give us the areas. So I can quickly solve for the ratio of area. Put that as A over 32. And then you can simplify it down. And my friends, always give fractions in simplest form. So always reduce it. So you're going to get the ratio of area as 1/4. But notice I'm not looking for that. I'm looking for the similarity ratio and the ratio of perimeters. So the cool thing is, all I have to do is go backwards for what my theorem says. If I know the ratio of the areas, it's just the similarity ratio squared, the inverse operation would be taking the square root. So the similarity ratio is the square root of 1/4. Square root of 1 over the square root of 4, 1 to 2. Then the cool thing is, if I know similarity ratio, I know ratio of perimeter, it's also 1 to 2, because again, look at the theorem at the top of the page. We know ratio of perimeters and similarity ratio are the same. And then for B, it says two circles with areas are similar. Now, we're not talking about polygons, we're just talking about similar figures, but the rules still say the same. Again, I'm given ratio of areas. So I'm going to write it just left to right. That's how I write my ratio of areas if there's no diagrams. And we get 128 pi over 18 pi. And a lot of people are like, oh no, panic, what do I do? There's a pi symbol. My friends, anything divided by itself is 1. It simplifies out. Then you reduce your ratio just like before. And I'm going to take 2 out of both, and I'm going to get 64 all over 9. That's your ratio of area. Now, again, that's not my final end result I'm looking for. I'm looking for the similarity ratio and the ratio of perimeter. So I take my ratio of area, and remember, I take the square root of my similarity ratio. Oh, excuse me. Similarity ratio is, I just said that completely opposite of what I meant to, so let's refix this. Your similarity ratio is the square root of your ratio of your area. So we get the square root of 64 over the square root of 9. So you got 8 over 3. And then your ratio of perimeter is going to be 8 over 3. Same thing because they're equal. All right, so now the next 2 examples definitely are calculator worthy. Also, you will see these again, okay? You have to be able to set these up. This is on homework, but this is also on quizzes and tests, so this could be really important to know for your test. You are going to use the same idea that we've done the last couple of problems. You're going to know one of the 3 ratios. You're either going to know similarity ratio, ratio of perimeter, or ratio of area, and then you're going to use it to find the missing information. So on this first one, on example 7, it says you're given the fact that triangle LMN is similar to triangle QRT. So I know they're similar. And I want to find the perimeter P and area A. So perimeter, don't know, and area of the smaller triangle QRS. But I'm looking at this and I have to ask myself, I have to have one of the 3 ratios we've been talking about. Either perimeter, similarity, or area. When I look at this, I see that I have a pair of corresponding sides, which means I can get a similarity ratio. And I'm just going to go to the bigger to smaller one because it's just left to right. So it's 13 to 9.1. You can change that to a fraction if you want, but you can leave it just like that. Knowing that the ratio of perimeters are the same thing, I'm going to use that to solve for the perimeter of the smaller triangle. So I'm going to set up a proportion with my ratios for perimeters, okay? So I'm going to set my ratio, it's 13 is to 9.1, is the same as the perimeter of the larger one, that's why it goes with the 13, which is 36 centimeters, to the perimeter of the triangle, excuse me, didn't mean to sneeze there, and you just match it up corresponding, big to small, and then we cross multiply. So I get 13 times P equals 9.1 times 36, and I'm going to divide by 13. Some of you will multiply first before you divide, that's fine. Now I'm just going to put it in my calculator. So I got 9.1 times 36 divided by 13, and I got 25.2 centimeters. Notice you just set up a proportion. Now I'm going to set up a proportion again for area. The ratio of area, if you remember, is your similarity ratio squared. So I'm going to do that real quick. I'm going to go 13 squared is to 9.1 squared. Well, 13 squared is 169. And then you have 9.1 squared is going to be 82.81. So now this is my new ratio I'm going to use because I'm looking for area. So I have to use the ratio of areas to find area. Kind of makes sense. So we get 169 is to 82.81 is the same thing as the area of the bigger one is. So 60 is to the area of the smaller one. So we cross multiply 169 times the area of the smaller one equals 82.81 times 60, divide by 169. All right, we're gonna do the math real quick. I'm gonna do it on my calculator if I don't sit there and type in something wrong like I just did. All right, what do we got here? Divide it by 169. All right, I got 29.4, and it's gonna be square centimeters. Does that make sense? All right. All right, keep going on the last one. Exact same process. I'm going to change ink color here just because it'll be easy to tell the two different problems apart. I look at this and I say, are they similar? And they said they're similar to us. This says find the perimeter and area of triangle ABC. So I'm looking for the area of triangle ABC. Well, my friends, we have to set up ratios again. Well, what ratio do I know? I know the similarity ratio. It's 6.5 to 13. Well, my ratio of perimeter is exactly the same thing. 6.5 is to 13. So I'm just going to set up a proportion. All right, so I'm going smallest to big. So I'm looking for the perimeter in the small one to the perimeter of the larger one. So it'd be 54. So that's why this one came last, because it was the larger value. Cross multiply 6.5 times 54. So we get 6.5 times 54. All right, so I get 13p equals 351. Divide by 13. P is going to be, I think it worked out nicely. This one's 27 inches. Make sure you label or they're considered wrong, my friends, so don't forget to do that. Then I got to find the ratio of area. Remember, that's your similarity ratio squared. So I'm just going to go 6.5 squared is to 13 squared. So 6.5 squared, that gets me 42.25. 13 squared is 169. So we go ahead and plug it in. So 42.25 is to 169 is the same as, remember, area of the small one to the area of the larger one. Cross multiply. And then divide by 169. All right, so let me get there. Double check my math. My friends, I got the area to be 31.5 square inches. Now, use these as guides to help you work through. Hopefully this video will help you be able to finish up your homework and everything, and I know you guys will do a great job.